Okay, we're looking at compound measures. So compound measures, and we're going to look at these all together, not just the speed one. Okay, so we're looking at what we call speed, density, which you might have heard of in physics, and pressure. Okay, you might have been told in physics about the formulas for these, but why we're called compound measures is because we use two different types of measure in its calculation. So for instance, speed is distance divided by time, and therefore its units are miles, for instance, miles per hour. The division means miles per hour, miles every hour. Okay, we could have kilometers per hour, meters per second, but you've got 1 unit, 2 units, so it's combined, and therefore it is a compound measure. Density, D, is equal to mass over volume. So mass could be measured in kilograms, volume could be measured in meters cubed. So you might have kilograms per, remember division means per, as another way of saying it, kilograms per meter cubed, grams per centimeter cubed, for instance. Okay, so again a compound measure because you're using two types of measure. Pressure, okay, is equal to force over area. Force over area. Force is measured in newtons, area in millimeters squared, for instance. So therefore two different units, therefore pressure is a compound unit. So we've got newtons per millimeters squared. Okay, so or in the old imperial measurements that the Americans use is pounds per square foot. Okay, but those are the three we need to look at, and there are ways of remembering these formula, which I'm sure you've seen before. I don't like this, but it works. Okay, it might help you to remember them because you've got to memorize them. These triangles. Okay, now speed always goes here, density always goes here, and pressure always goes here, and that over that, distance over time, distance over time, mass over volume, mass over volume, and force over area. And just in case you haven't seen how to use this, if you wanted a formula for distance, you cover distance up, and because s and t are on the same level, they're times together. So if on the same level, it's times. So distance is equivalent to speed times time. If you wanted time, a formula for time, you'd cover time up and you'd realize it is d on top of s. So distance divided by speed will give you an answer for time. Okay, and they all work similar to that. So we've got, for instance, mass, I could cover up, is equal to density times volume, and volume could be found out by doing mass divided by density, mass divided by density. Okay, and finally, if you've got if you want to find out force, you would do, because they're on the same level, pressure times by area. And if you wanted area, for instance, and you've got a force, you would divide it by its pressure to work out what the area is. Okay, so that's how you can get these different formulae, and that's how these triangles are used. So you now understand why they're called compound measures, because you're using two different types of measure. So for instance, if I measured a distance in centimeters and a time in hours, then the units for that answer of speed will be centimeters per hour. Okay, now it's not a used, it's not a usual unit for speed, but it exists. Okay, so centimeters every hour, something like that, speed of plant grows or something, I don't know. I can't even think something that moves so slow in 70 centimeters per hour, but you get the idea. Whatever units you choose here divided by whatever units you choose here. So more importantly for us today, we're concentrating on this, and we will be using the standard ones, which units of speed, the meters per second. We will be using kilometers per hour, and we'll be using miles per hour. So if I want something in this, then that has to be in miles and that has to be in hours, and if it's not in hours, I need to convert it, and there's ways of doing that. So I'm just going to quickly look at time conversions to help us today. So if you look at time, there is a button on your calculator that looks like, see, that looks like that, just there. Okay, so you've got like apostrophes almost and speech marks. Now, if you've got a Casio, that's what the button looks like, and sometimes it's called your DMS button, degrees, minutes and seconds. Okay, and it now puts things out of 60. Okay, so there's 60 minutes in an hour, there's 60 seconds in a minute, so it's all that button allows you to do that. So for instance, if I want to put something like 2 hours 33 mins and work that out as a decimal in terms of hours, then what I would do is the first input is always your hours. So if you've got no hours, you'd have to put 0, so that's 2 hours. You've got 33 minutes, 33, those are your minutes, come second, and there's no seconds, so I need 0 seconds. And don't forget to finish off by pressing that button again. Press equals, and you'll see it comes up like that, 2 hours, 33 minutes, no seconds. If you press, I think SD, you get the fraction or you get the decimal. So 2 hours and 33 minutes is exactly 2.55 hours. Now some people stupidly think that if I wrote down 3.15 hours as a decimal, that means 3 hours and 15 minutes. That's utterly wrong, because what you're assuming is that this is decimal system, so you're over 100 here, you're assuming there's 100 minutes in an hour, and there's not. So don't fall down that pitfall. Okay, so that's how you convert hours, minutes and seconds into a decimal equivalent of just hours. Okay, and you can also put in go backwards. So if I get my calculator, I see it all, I could put 2.55 into the calculation, and not that button, sorry, delete, press equals, and then press that button and it converts it. So I can convert anything, so 2.46, press answer and it comes down there, and then convert it into, so 2.46 hours would be equivalent to 2 hours 27 minutes 36 seconds. Okay, so very important button to convert from hours, minutes and seconds to just hours, a decimal equivalent to hours, but it also goes from your decimal hours back to splitting it up into hours, minutes and seconds. Okay, right, why is that important? Well, if you have a look at some of these questions, so I always famously say that when I was really fit all those years ago, I used to cycle this 29-mile circuit, and I would do it every other day, and I did it for years. It was mountain, well, very, very steep hills, really a tough course, and it was a 29-mile course, and I can remember going really, really fast, as fast as I could for the entire journey, and try to beat my record. My record was 1 hour 33 mins and it was 11 seconds. And let me tell you now, I could taste blood. I was going that fast, you know, so you know, really fast. So the average speed for the entire trip is your total distance of the trip, including stops and all that, but I didn't stop, and divided by the total time it's taken to get from beginning to end. So first of all, you need to convert this into a decimal equivalent of hours. So that's where you get this button. Okay, and you do 1 DMS, 33 DMS, 11 seconds DMS. Press equals, SD it. Oh, I pressed that again, sorry, there we go. I don't know why it didn't work then. So you press that again. The SD didn't work. Just press that again, it converts it to a decimal. So roughly it is 1.553 ... hours. That's what that is equivalent to. Okay, so the speed, as you know from your triangle, is distance over time. The distance I've got is equal to 29 miles. That is the units I want. Okay, and the time in hours, just in hours, is 1.553 ... unrounded because it's not the final answer. So what we end up with will be an answer of miles per hour. Miles per hour. Okay, so I'm going to do 29 divided by my previous answer equals. Now the calculator doesn't know it's not supposed to be a time answer, so if we press that button again, you can see that my average speed for the entire journey of this mountainous track was 18.7 miles per hour. I wish I was as fit as that again. Okay, so it's a compound unit because we've got one unit miles and another unit hours, all wrapped up to make a speed. So it's a compound. That's what's a posh word for it. Okay, just one more example. I'm just trying to think of this. Right, so if I've got a snail and it is I've got no idea. Let's not say a snail. I don't know, a particle, because I've got no idea. Let's say it's doing 27 centimeters in, and it takes it, I don't know, 29.3 minutes to do that. So that many centimeters per minute. But we want our answer, we want the speed to be in meters per second. Well, the first thing you're going to have to do is convert these units. So that will be in meters. Well, if you remember rightly from our little diagram, which I'll quickly draw again, so kilometers, meters, centimeters, millimeters, going down there, down there, down there, you times by 1,000, you times by 100, and you times by 10. And to go back on yourself for completeness, divide by 10, divide by 100, and then finally you divide by 1,000. So if you want to go from centimeters, which is just there, and you've got to convert them to, and you want them into meters, well, you're going that direction, so you'll need to divide by 100. So 27 divided by 100, well, the decimal point's right at the end. It's now going to move once, twice, because I've got two zeros. Once, twice, so the answer is 0.27 meters. So I've got that converted. Now the next one is I need to convert that into seconds. Well, you know that there are 60 seconds in every minute. So if I've got 29.3 minutes, I'm going to need to times that by 60 to get me into seconds. So 29.3 times by 60, and that will convert that. So 29.3 times by 60 seconds, and we end up with that. So 1758 seconds. So we've got that now. Now we know that speed is equal to distance over time. And if we want the answer to be in meters per second, well, this needs to be in meters, and this needs to be in seconds. Well, I've converted them, so it is the equivalent of 0.27, and I'm dividing it by 1758. So my final answer for that, for the speed of that particle, would be 0.27, and I'm dividing it by, so per, that's what that line means, 1758, and that equals that, which you should know is a standard form number. If I write down 1.53, was it a 5? Did it round up? You know, to 6. I'll round to 3 dp on that. Times by 10 to the minus 4. Now you should remember standard form. What that is, because you've got a minus, is a very small number. It means that this decimal point is going to move 4 places this way. 1, 2, 3, 4. So that is equivalent, for instance, to 0.1233536 meters per second, and that's the answer. It's fine to leave it in that format. Okay, I'm just trying to make you understand, a bit of revision, what standard form is, what that actually means. Okay, so I hope that helps, and why it's a compound measure, how to use the DMS button. But that's the first video on speed that you cover that. It should help with the second one as well. All right, I'll end it there.